And we're live! Brought to you by Nabisco. Is there glare coming off of this? If there is, you can hit the second to the top light there to the second to the top button, I think. No, from the very top, the second to the top. I think that should turn this one off. Ninja?
Just mood lighting.
Huh?
Just mood lighting.
It's mood lighting.
Let's
See if I have the match. Yeah, looks like the right one. Now there's the third one. Fourth one down now? No, you're back on. That's all of them. Ish.
I got rid of the glare.
Yeah. All right, let's go. This really has always been the one. All right, I think that's what I was trying to do. So it's the third button down. But yeah, it was actually fun. Okay. So let's go over the syllabus thing here real quick, and then we'll start talking about stuff. Can we read that okay?
Yep.
Okay, so this is game programming 1, blah, blah, blah. This is me. You can call me Mike, Dr. Lippman. I'll answer to whatever, yo fatty. I am not a very formal person, so feel free to, a lot of students just call me Lippman, so whatever. This is my cell phone number. You can call it if you want, but I probably won't pick up. But text and email are the best ways of getting a hold of me, especially text. So if you have a question on your homework or something like that and you want a fairly quick response, text me and there's a pretty good chance I'll respond pretty quickly. All right. The other thing we'll talk about in a few minutes is our Slack channel, which I think everybody in here should already be on. So we don't really need to talk about it, but I'll create a 355 thing on there. That's another good place to post questions and that kind of jazz. Okay, so blah, blah, blah. Stuff, more stuff. Homework assignments, 45% of your grade. Quizzes will be 15% of your grade. Actually, I'm going to change this. I'm going to combine these two. That benefits you. Because if I only give like 2 quizzes and you miss one of them, then that destroys your quiz grade. So I'll actually have homework 45, quizzes, well, homework 60%, quizzes part of homework grade. So it'll be 60% total for those. So if you miss one quiz, it's not a destructive force on your whole grade. Then midterm and final, 20% each. I have a policy where if you do better on the final exam than you did on the midterm, I will replace whatever grade you got on your midterm exam with the grade you got on your final. So if you screw up at midterms or stuff just hasn't clicked yet, you have a redo on the final. So everybody understand that? Okay. Interesting. Normal grading scale, 90, 80, 70, 60. Lower 2% is the minuses. Upper 2% in those is the pluses. So like an 88 would be a B plus, an 87 would be a B. An 82 would be a B minus, an 83 would be a B, that kind of thing. And then Christian framework for the class. You can go ahead and read through that if you want. I'd encourage it. All right, questions about the syllabus in general. Kind of know how you're going to be graded and that kind of jazz. Okay, now let's talk about homework assignments. Every single week, you will have a Bible homework. It's due Sunday before midnight each week. So I'll try to get it up at the beginning of each week, but sometimes it doesn't get up until, middle of the week or something like that. It's basically read one chapter out of the Bible that I give you, and then you have to write 1 or 2 paragraphs reflecting on how it relates to your, relates to computer science in your case. All right. So Concordia, we're supposed to integrate a Christian worldview into the classroom. This is my way of forcing you to read some of the Bible and reflect on it. Should only take hopefully less than 10 minutes, and it's a free homework grade. All right. Makes sense? So everybody's cool with that? All right. Now, let's talk about what we're going to do in here. All right, all of you, before next class, will need to follow this link here that says required video course. We're going to be going through a course from, let's fix that link, shall we? The link's right, but the link doesn't seem to work. We rename the link? Yeah, just in case. I'm going to rename the link, the whole link, in case for some reason it doesn't click. Then you can just highlight it and copy it, and it's going to take you here. Create your first RPG and FPS multiplayer game in Unity. It's $10. It says 1 day left at this price, and then it goes back to $195. I've never seen it for more than $12. So get it today, and you'll have it for $10. All right, and I'll come back and talk about this in a second. For a moment here, though, let me go ahead and open up Slack, and I'll create the 355 channel. I'll just paste this link in there. So you don't have to screw around with copying and pasting or whatever jazz. All right, I don't think we have a 355 in here because the class used to be taught as 275. CSC355, public, create channel. There. All right, so go on to Slack, go into the 355 class, and there's your link for the thing. $10, get that. That's your textbook for the class. Cool? Cheap enough? All right. Now, we will spend some time here in class watching some of these videos, but then I'm going to pause it pretty often and interject stuff. All right, so then I'm going to give you assignments outside of class where you'll finish watching a video or watch a part of a video and complete some aspect. I'm going to talk about the video here in a minute. Okay, so inside this thing, you actually create several different games. We'll start off probably next week creating this kind of first, it's kind of an introduction type game where they're not really trying to teach you game programming as much as just teaching you how easy it is to accomplish some stuff in Unity. All right, so now most of you have been to our hackathons on campus, except for you, but this guy, new guy. Have you ever? So most of you have used Unity a little tiny bit, or sat there and watched somebody else who knew how to use Unity use it, right? I'm going to assume you have zero experience with Unity, so we'll go back over stuff and think about how things work. And there's a couple of things that actually changed in the newest version of Unity. We'll make sure we grab that here in a few minutes. But in any case, we will be using the Unity game engine for this class. And what we're going to write in, well, we'll see how far we get through the course, but there is an initial game that just kind of shows you how easy it is to do things. It's like these pumpkins are rolling at you and you got to dodge them and stuff like that. And then what we did last year is we actually converted that to VR, and it's terrifying seeing these giant pumpkins rolling at you, and you got to dive out of the way and stuff like that. So we might do that just for fun. And kind of see how easy it is to move things into VR from just normal 3D gaming, although we're going to be focused on just doing it in normal 3D because not all of you have VR headsets at home to test it. And I assume you don't want to have to come in to do your homework every single time. So the next thing we do is this thing called Awesome Night, which is kind of like Diablo 3. So we're going to create a game along the lines of Diablo and how that might work and how the different movements work and killing stuff works and that kind of jazz. After that, there's an RPG, kind of along the lines of, trying to think of a good comparison. Why is the name not coming to me? You know, one of these hack and slash type games where you're moving all around in 3D space, but it's less about clicking to move like Diablo. And why can't I come up with a name of a game? Name some of these hack and slash type games that are on these systems today. I literally have 3 of them like on the tip of my tongue. Well, one will pop into my head before too long. And then the last thing, if we get to it, will be a first-person shooter. But we will, if we do something with the first-person shooter, it'll be just a little tiny bit anyways. It's kind of like an add-on because next semester we're going to be looking at a lot more network programming and game programming too, where you have multiplayer games and think about all the things with databases and that kind of stuff. So in any case, that's what we're going to be going through in here. We will at least get through this Awesome Night thing. It'll kind of just depend on the pace of the class, but you know, the difference between the Awesome Night and the, here's this Awesome Heroes RPG game thing. Here, I'll just show you the preview of it real quick. And you're going to love this guy when actually, it should come through the TV.
What is up, guys? Roger here from awesome.com, and welcome to our RPG game section. And this is the preview of our RPG game that we're going to create. So I'm going to hit the run button right away, and we're going to see a nice, beautiful main menu with a nice transition camera. And I can click on play game. We can go here to the character, select system. I can go back also in the main menu and go back to the options, or click on options, change the graphics quality. So if I set on high, notice we have shadows, ultra, we have even more detail. Click on back to low, then we don't have no ultra, no shadows, we don't have the shadows. So this is also one of the nice features that we're going to implement. Keep in mind this resolution, we can click it, but it will not do anything. Export our game, for example, on Mac, and then it will do things, or it will change the resolution. But we will see, of course, how we can do that. And this right here, the graphics quality is very nice to keep your game playable on computers that have less graphics or RAM or whatever. And moving forward, if I click on the play button, we are in the character select system. I can go into create character and I can choose king, I can choose cat, I can choose 9 to see different characters. I can click on accept and I can click on start, and bam, we have a nice screen transition, loading screen, and here we are in our level. I can zoom in on my character. And also we can, rotate the camera with the mouse. I can attack, and I can also attack with a special attack, as we just saw here. I can click here on the item, and then we can select different items. So we have the fire sword, magic sword, basic sword. We can click on the items here again and turn that off. And click on the tab to lock the mouse again. If I go over here, for example, we will see that we have a button that we can click to go into different worlds. We have the wolf world, orc world, sky world. If I go here into the scene, we also will see here that we have some people that are walking around. So notice there is one of these. Let me just find the other one. So where is the other? Yeah, here he is. They are walking around like in an RPG game. Here we have our enemies. So one of the enemies that we're going to have are the wolf enemies. So here they are, and they are patrolling over here until they reach our player. So this is also where we can battle them, but we can also go here into the sky world, or maybe orc world or wolf world. In order to click it, we need to unlock our mouse with the tab. Click here, bam, loading screen. We are in the wolf world, And here we can fight wolves, so we can zoom in on our player and we can go and search for these wolves. I see one of them right over there, so you can go and fight them also. And if I try to, fire my special attack, let's try to hit them. Well, no, nothing works. But I'm gonna go away. Anyways, we see they are following us and they are trying to kill us and whatnot. So we will see all of that. We will see the combat. We will see how we can do all of these good stuff and how we can create that character select system, how we can go back, navigating back to my village. I can go in different levels. So here we have the orc world where we can fight orcs. So again, voila, here we are, and we can go past the bridge, follow, or go here, passing the bridge, and over there we can fight the orcs. But I'm not going to do that since I'm going to show you the last level that we also have, which is, our Sky World, where we can fight fire golems. So here we are going back to the village again, making that transition. Here I'm going to go back to, or travel to the Sky World, and over there we have these fire golems that we can fight, and we'll see all of the good stuff. So you'll see all of this right here in our game preview. Now keep in mind, I wanted to make this a full scalable RPG, but I soon came to realize that it's really hard to do that on my own. It takes a lot of time, a lot of resources, so I probably will cover that in a separate course. Only dedicated to the RPG game, adding inventory as we have here, but I will add the progress system where we can progress from level 1 up to level 100, so on and so forth, have shields, different weapons, and all of the good stuff. But here I have created a smaller RPG game to give you a sense how that goes. We saw we have different worlds, we have people in our game walking around, we have enemies, we can fight with them, we will create their AI, we will see all of that, great stuff. So don't want to stall anymore because we want to jump in and create this awesome game. And Fabio here from awesomedudes.com. Thank you for watching this preview, and I will see you in the next video.
All right, so that will be the second game we look at if we get to that point after the first one, although you'll see once we get through, if you want to see what this first one looks like, this awesome night one. This is effectively like Diablo 2 or 3, however you want.
What is up, guys? Fabio here from awesomedudes.
I'll just jump forward a little bit. See.
Cool features in this game, such healing ourselves and even throwing thunder. If I go here into the sea view, this is our level. These are 2 enemies that I've added, and of course, I've added 2. Gel. 2. This is the second.
Yeah, so you see kind of how you have this 1, 2 through 6 for your different special abilities, and you move around by clicking, and your guy will go ahead and path around things, stuff like that. So you'll notice that there's a lot of information, a lot of things that you'll learn in this one that are just repeated in that second game, and then you just kind of look at the different genre of game and maybe how the fight system might work differently rather than just hitting like auto attack and stuff like that, where you actually might do swipes and things like that. So it's not a whole new experience. It's a 25% new stuff, 75% practicing things you've already learned type thing. Kind of makes some sense. And then the first person shooter is really simplified if we get to that point, but we'll be building something much more involved next semester when we do and it really doesn't matter whether it's a first-person shooter or an RPG or whatever. When you start bringing in database and networking stuff and multiplayer all existing in the same world at the same time, these are all part of what we expect from our games today, right? How many of you in here have ever played one of the Diablo games? Diablo 2, Diablo 3, game like that? Never? Just sticking to Hello Kitty and the Island Adventures. Did you ever unlock the purple dress?
Oh, yeah, really well.
Yeah, we got that.
I've been too busy with Doom.
What's this?
I've been too busy with Doom.
Well, yeah, so Doom would be a first-person shooter, right? Yeah, so, but in any case, if you've played Diablo 2 or Diablo 3, you can create, like, the default game is solo. You're going through, you're playing the levels, you can set how difficult it is and stuff like that. But then you can kind of create like a shared game with up to, I don't know what Diablo 3, how many people does it allow you to have? I know Diablo 2 allows you to have, I think, 5 people in the shared world. Diablo 3, I think, is more. But whatever, you can create a game that you can invite other people to, but it's you don't have this one central world that all 5,000 people playing the game are all joined into.
Not an MMO.
That's it. That's it. Yeah. So it's not a massively multiplayer type of situation. That's the type of thing we'll look at next semester when we have to start thinking about, network balance and how does one person's system perceive movement from other people, where we need to get information passed kind of in real time. If you we think about it in a first-person shooter. It's really important. If you and I are playing a first-person shooter and you move a little bit, I should see you moving my screen, right? Because I'm going to be aiming. I need to be aiming at the real McCoy, not where he used to be. Even a quarter of a second ago. So we really need to think about performance, network performance from that perspective, and how do you make it relative real time. And one of the things you've seen, so most of you have probably played a first person shooter of some kind, right? Now, when you go and play an FPS, when you think about your network, what's the most important aspect? Okay, and that's measured in what? Latency. Yeah, latency or ping. Right. So, they usually give you the green color. If your ping is like a 21 or a 27, that's milliseconds. So 1,000 milliseconds means you're updating every 1 second. So 26 milliseconds means you're updating often, right? Very, very often. So the lower your ping, the lower your latency, the more often you can communicate with that server. Now, you're still, that's saying this is the complete turnaround time of me hitting the server that's serving this game and getting information back from it. That doesn't necessarily mean the server is going to send you information at that cadence. Because one thing you want to do is you want to make sure it's an equal playing field for everybody. Right. So if you're getting updates every 26 milliseconds and you're getting updates every 75 milliseconds, which would still be considered a reasonable ping, now all of a sudden you have an advantage. So the game makers are likely going to create some sort of, what they consider is the acceptable update time. And that's going to be probably meshed with whatever the refresh rate is. And these are some things we're going to start talking about here in a few minutes. But in any case, it's we're going to talk about those challenges of creating an equal user experience across the board with the things we can control. Obviously, if somebody's playing on a really, really, really crappy, like satellite-based internet connection, we'll talk about actually that here in a few minutes. But just to give us our baseline for the technology we're dealing with, and they have a 5,000 millisecond refresh rate, we're probably not going to play to that as your lowest common denominator. We're probably going to assume a refresh rate of or a ping of 100 or better.
Chinese guy.
Yeah, who's on some island. He's on some island with really bad internet. He's got the rabbit ears. He's hacked into an internet connection. All right. So in any case, those are the things we're going to be creating in here. Now, this looks pretty decent, right? Something that when you walked into the room, maybe you didn't necessarily assume that you could create something that looked that legit. And keep in mind that we're going to be using pre-built type stuff to create these environments, but the tool we're going to be using, Unity, has all sorts of stuff that you can download for free or even pay for from their asset store to get stuff that looks this good or even better. So that then comes back to our idea as game designers, we want to focus more on what the game is, how the game needs to work functionally, and then maybe let somebody else worry about how it looks. All right. So questions about any of this stuff? So before next class, everybody should go out to Slack, go to the 355 class, follow this link, and go and buy that thing off Udemy. I think you might even get a bigger discount if it's the very first Udemy course you've ever bought. Create an account on Udemy, maybe it'll be $8 or something like that instead of 10. In any case, way less than most textbooks. All right, so get that for Thursday. We may not actually start it for Thursday, but there's going to be some things we're going to start referencing in there leading up to it. It's going to be one of those things where why aren't we doing the game stuff first? Well, there's a programming aspect that we have to talk about as well. That's also covered in the course. All right, so let me go to here, and I'm going to create a slide set for us. I don't want pages. I want Keynote. Oh, plus. All right. And I'll create a link for this presentation and put it up on our Blackboard channel, so it'll be shared with all of you. So this is CSC355. Game Programming 1. And 355, fall 2018. Okay, and then collaborate. Anyone with link can access it. None of you can change it. Actually made that error one time in the past. And once students start getting to know me and decide they want to start screwing with me, they were changing the presentation in the middle of class and put some inappropriate stuff up there. So it's whatever. All right, so let me go ahead and create this web link. I'm going to actually name it. I should be able to name it course slides. I should be able to provide it with the link available to users. And that should update, like open up. Okay, the problem is it's trying to launch it inside the browser. Can I edit it? Oh, set link to open a new window. I bet you that's it. Yeah. Yeah, it didn't like, it's probably still trying to share, or I have it open on the other screen. But yeah, it'll work now. So if I just do this one, those two guys didn't like loading as a frame inside of another app. Now they should work. Okay, so let's start talking about game programming. All right, so we've seen some of the things that we're going to create now. When you first enrolled in this class, or when you first heard the phrase game programming, what did that mean to you? What do you think you're going to do as a game programmer? What are the aspects of game programming? Go ahead.
Program movements of a third dimension.
Okay, so assuming we're doing 3D gaming, one of the things you have to focus on is how does the player move? So one of the things is going to be controls. Is this a keyboard and mouse game? Is this a Xbox controller game? Is this just a mouse point and click? Whatever. We have to conceptualize what movement might be and then write the necessary magic to make that happen. Okay.
So you want to create as many as possible.
Mm-hmm. Okay, so one of the things, and this is maybe the hardest part of game programming. Now, all of you in here, I assume, are gamers, right? At some level. Have you ever played a game that looks really, 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 really good, but the game just sucks? Yeah. So one of the challenges of any sort, well, let's go to the flip side. Have any of you ever played a game that was just amazing to play but looked like crap?
Fortress.
Well, you see what I'm saying, and that's actually come back some now because we have some of the 8-bit type of almost genre games that have come out that are actually quite fun. How many of you played the original Final Fantasy game?
I played Final Fantasy 2.
Okay, that would still be the same type of game.
Final Fantasy 4 with
Yeah.
2 in the United.
Yeah, but all the newer Final Fantasy games are more of the RPG thing that we saw with the 3D world. So like we look at these are old Nintendo games, these 2D games, and these games by today's standards basically look like a flip book, right? There's nothing impressive about them, but the significantly more focus was put onto what the actual game was, storyline, things like that. And now sometimes you have these games that come out that are so focused, and we see the same thing in movies, right? Where there's like no storyline because it's just all about explosions and graphical effects and things like that, which is okay. I mean, that holds your attention for an hour. But then all of a sudden, when the game isn't fun to play and you've seen all the cool explosions and things like that, there isn't a whole lot to it. But so as a game designer, and you really want to use this idea of game programming loosely because game design involves lots of different skill sets. All right, so we even replace this word programming with design. So one of our skill sets is going to be a programming skill set. Right. Another one of our skill sets is going to be a design skill set, making things look pretty. Okay. Another skill set is going to be kind of the storyline writer type skill set. This might be just that idea person, the person that sits there and says, "Oh, well, we should have a game that does this, and the way we fight things is like this." And a lot of times, those are just game addicts who play 5,000 different games and have this idea of what they think an awesome game would be. Even if they don't have that programming skill set or the design skill set, they have conceptualized what the whole game might be. So now they're the ones who can then bring the idea of the game to the center and then let these other skill sets actually execute the thing. And this is something that transcends game programming. This is in normal computer science as well. If you are a business application programmer, you're going to have, some company comes up to you, maybe the company you work for, or maybe you're a freelance developer, and they're going to say, "We want this." And whether you agree with it or not, or whether you think it's a good idea or not, you are the one who's executing their wish, right? They say they want something that does A, B, and C. You're going to write an application that can do A, B, and C. So you're performing this programming skill set. Or if you're more on the design side of things, you're providing this design skill set. Now, and if you've had some other programming classes with me before, maybe you've heard me talk about this little comparison. But one thing you maybe see, types of programmers. All right, so a lot of times I'll reference this as a native programmer versus a web programmer. Okay, now if you're a native programmer, that is, you're writing that back end code, you're comfortable in like C and C++, not really user interface focused, but you know how to code. Data structures are a really easy thing for you. You're writing all this crazy algorithm stuff, blah blah blah. You consider yourself a native programmer, or if you talk to one of those folks, they would consider themselves a real programmer. Okay. Now you have the web programmer. Okay. From a native programmer's perspective, the web programmer is like the programmer for dummies. Now, here's the issue with that. Web programmers are often not having to write the same level of algorithms as a native programmer might. That doesn't mean they can't. That just means it's not necessarily part of their daily job because they're typically writing stuff that is commonplace on web pages. That kind of stuff. And there's a lot of tools already out there for doing it. But if you're a web programmer, you also need to focus on design, right? Even if you're not the ultimate graphic artist who's making the logo or something like that, you're going to be the one who's working with layouts and all these user interface stuff that are important aspects to the website. That's a skill set that most native programmers do not have. So really, I would consider a web programmer to be much more of a cross-training type skill set where they're a programmer and they're a designer, or a native programmer might be, maybe that's more of a 60% programmer, 70% programmer, and then 30 or 40% designer, or native programmers probably 90-10, something like that. One's not necessarily better or worse than the other, but now we're in the situation of what's the right tool for the job? What kind of skill set do we need for the job? So when you think about that from a game programming or a game design perspective, what type of programming skill set do you think we want for a game programmer versus a designer? Which of these two guys do you think fits best into the game programming world, and why? Okay, that's a that's a cop-out answer. All right, defend it.
So on one hand, especially if like in like this class, if we don't have people like designing like assets and stuff, whereas we have to know how to program and how to like design stuff.
Okay. I'm thinking more along the lines if you go and work for Activision or, so Blizzard Activision or, a big game company. If you're applying for a job there as a programmer, what skill set do you think they're looking for?
Probably native stuff.
Yeah, so they're probably looking for the native programmer type of skill set. Why do you think that is?
I mean, their like engines probably much more complicated. There's a lot more programming, and like, especially in like AAA titles, there's a lot more going on. Programming, physics.
Okay, so when he says AAA titles, he's talking about big budget games, right? Games that have a lot of money behind them, and there's a lot of developers working on it at the same time. These are not your indie developer who's writing the game with him and two buddies out of the basement. Okay, these are big type games. Go ahead.
So the program that you're looking for is loot box programmers.
I mean,
APAs.
yeah. There's a lot of algorithms involved. Now, we're going to talk about a game engine here in a few minutes. So I think the complexity of physics and things like that becomes a little bit of an interesting thing. So, for instance, we're going to be using a game engine in here called Unity, and most AAA game developers are going to have their own internal game engines that they've evolved over the years or something like that. And those game engines are going to do kind of the basic stuff for you, just like Unity. Unity, we can use their built-in animation stuff. We're going to use their built-in AI stuff. We can say we want this guy to go from this point to this point, navigating around things that he shouldn't be able to just walk over, and use their built-in stuff. Now, if you are writing a little indie game and stuff like that, you might decide the way that Unity has this built in that's easy to use, relatively easy to use, is good enough. If you are a AAA game writer, you're writing, a game that's going to be in front of a really discerning audience, let's say, maybe the built-in stuff isn't quite good enough for certain scenes, certain things in the game. That's where a native programmer might really need to get down there and write their own pathing algorithm or something like that for a specific scene to make the guy not look like he's walking through tables and stuff like that. All right, so you really need a kind of a more dynamic skill set where this person here can solve programming-esque type problems that are thrown in front of him. Whereas maybe the average web programmer, not all of them, there's plenty of native programmers who became web programmers because that's what the job was. There's nothing wrong with that. So you can't judge a book by its cover, and there's plenty of idiots that call themselves native programmers too. So, but if we're talking about the underlying skill set that you would expect from these web programmers are kind of that halvesy, close to halvesy type of skill set. And typically, if you are a big game company, you're going to hire dedicated designers, where that person doesn't know how to write one lick of code. Okay, or if they do, it's 2% of their knowledge base. Instead, they can do 3D modeling and all this other stuff at a really, really, really advanced level to make things look good. So they're making things look good. The native programmers are making things, taking what they've made look good and making them work well. And we're going to kind of see that example in here because initially, when we start playing around with Unity, we're going to be using their built-in primitives like spheres and cubes to make them move around the screen and drop and use physics and things like that. And that's not going to look pretty. Like if you went out to the PlayStation store and downloaded a game that was all done with, white cubes and spheres. Although we've seen some of those, a lot of them were like almost like the flying through space games. I've seen them in VR mostly, where it's all just primitive types, but it's kind of fun still because you're in VR and you can kind of leverage it. But in any case, that's not impressive looking. Okay, so we're probably looking for more of that native skill set. Now, when we talk about game engines themselves, what is a game engine? I mean, we've heard this phrase before, but when we think about a game engine, what are we expecting from it? What do you think a game engine is?
Like a toolbox full of tools to help make the game.
Okay. So, yeah, a power tool that allows us to make games. All right. So, for those of you who had some programming stuff before, several of you have gone through our upper division classes. Some of you have just come through 200. We used a text editor that was for Python that was built for programming Python. It would do all the color coding stuff and things like that. And some of them, we would have a play button up at the top to actually run your Python code, something like that. If you're a Java programmer, 250 this semester, we're going to be using Eclipse to do some Java stuff, which is a tool. It's just something that wraps around a text editor for writing Java, but has all the Java is easier with using this tool stuff built into it for doing Java stuff. Then we're going to be using Android Studio for writing Android applications, and that has all the Android interface building stuff built in, so you don't have to learn 10 different tools. It's a single tool that you learn, and yes, programming is an aspect of it, but there's also a whole bunch of built-in stuff that you're becoming experienced in using and leveraging and bringing into your application. All right, so a game engine allows us to write code. That's one of the things. Probably the biggest thing that game engines give us is physics. So things like gravity or how to solid bodies, or what Unity calls them, rigid bodies that have a mass. If they smash into each other, what should happen? Making it work as closely to how real life works as possible, right? We do have to consider, if two people are running at each other and they collide, physics isn't quite enough to tell us exactly how they're going to react, right? Because each of those people has a mass. And if we leave it at that, then we're going to, have some sort of physics response. But now you have all sorts of, if one of the guys is all muscle, the other guy is really fat, the fat's going to absorb a lot of the blow. And, you're going to have different equivalent masses that hit each other might look different when they bounce off, something like that. So we have to have a way of kind of mimicking what real life sort of looks like. That's what the physics is doing. So if you think back to the early days of game design, back to like Mario Brothers and Super Mario Brothers, things like that, when Mario is jumping, they had to create that downward force that was kind of like Mario's fake gravity, right? And when you're playing Mario, you're not really thinking about Mario as being this a real person that weighs 175 pounds or something like that. Mario kind of had this perceived mass in your head. So you knew when you had to jump for different things. And that was kind of trained into you based on how the physics of that game was written, right? Because Mario could, based on his height, he could jump up onto things you shouldn't be able to jump up onto, right? I mean, I have those kind of hops, but most don't. We weren't using a realistic physics engine there. We were using something that made the gameplay work, and that's okay. A lot of our games aren't necessarily based on real life, but it seems like the current trend in gaming seems to be moving towards more and more realistic, especially in the first-person shooters. We're having a lot of war stuff and things like that where you want it to feel real, real, right? So now we rely on these physics engines to be as realistic as possible. And if you imagine, if you're a programmer, you can spend 90% of your time writing code that leads to, physics, or somebody else, for instance, the Unity people, can write this physics engine, this game engine that has a heavy emphasis on physics, and say, here's a bunch of tools. These are all pretty good. These will work for, let's call it 95% of all games. Use our tools. Now you can focus on the normal programming. Programming, as you point out, like the controls. What happens when I press left? What happens when I press right? What happens when I press A? That kind of stuff. You're writing the code for working with that stuff rather than having to focus on the physics things. Unless you're in a very specific situation where the built-in physics just isn't looking right or something like that. Then you can go in and tweak it, but it's an exception, not the rule. That kind of makes sense? All right, so the game engine is giving us physics, and that's a big deal. That's something we rely on quite a bit. And, even though it's this nice little short word, you can imagine all the different things that play into physics and how that plays into games. Even just gravity and collisions are two things that are really, really, really important that we rely on looking pretty realistic. Okay. Another thing that physics, that game engines give us now is AI, artificial intelligence. What does that mean in a game?
Means basically anything. It's basically like it's a bunch of things. It's the pathing AI. It's the so it can be for characters that you don't control, or even in the case of RPGs, characters that you do. RPSs, real-time strategy games, characters that you do control as well.
Okay, so AI is for things. Well, the first thing he mentioned was pathing. So if we're going to see it in the first game we write, the first real game we write, not the first practice game thing, but we have our dude and we click over on the screen way over there, and in between me and that is rocks and a house and stuff like that, things that I shouldn't just walk through. If in our game, if we don't set those things up to be rigid bodies, if they're just, eye candy, we'll just walk right through it, no problem, which is, the efficient way of getting to your final point, but isn't going to be all that believable by our end user, right? If you're sitting there walking through cabins and stuff like that. Now, as a game player, every now and then we'll forgive them a little bit if it seems like, oh, did he just walk through that bush? Little things like that. But if he's just dead walking through the middle of a house, okay, or through rocks and stuff like that, we're not going to tolerate that, right? So where pathing comes in, and we'll talk about some pathing algorithms. There's a pathing algorithm called A-star, for instance. So, some mathy person at some point, I knew the guy's name at some point, we'll look it up when we get to that, came up with his algorithm and says, okay, think of the world as a big grid. You want to get from this box to this box. Now, between you and that, there's some of these boxes that are flagged as not walkable boxes. Okay, this whole area here that has the house, can't walk in those boxes. You got to get around those boxes somehow. So now it's a matter of finding the shortest path between 2 points. Now, and that's where the pathing stuff comes in. And, Unity allows you to kind of mark things as either walkable or not walkable. And then it allows you to create what's called a navigation mesh that you can make your dude then a navigation agent. What's a navigation agent? It's a dude who knows how to walk on nav meshes. No problem. So when he takes his steps, he's following the rules of, I can't step there, so I have to go here. I have to go here. I have to go here. And it's doing all that for you. So setting up pathing takes 30 seconds once you know how to do it. It's not necessarily trivial. You might not stumble upon those features, but once you know the 2 or 3 little tools you have to use to accomplish it, Unity's doing all that work for you to make your guy path through places. Now, sometimes things get a little bit sketch where you need to start thinking about, is shortest path really what we want? If you've been in one of those games where, somebody's walking from one point to another point and technically they didn't walk through a house, but they took a path that a human wouldn't have taken. Right.
One of my favorite games is Star Wars Empire Wars, a strategy game, and you constantly have to fight the having AI on the ship.
What, do you get stuck on stuff?
They get stuck on each other.
Oh, okay.
Like the ships will constantly just kind of.
Yeah. That is something.
Like when the ship's in the way while it's still moving to your position, the other ship that's trying to move into position next to it will just start turning around and going around the entire asteroid.
Yeah, and that's something, using the words I just used in the last few minutes. If you have a single navigation mesh and you have 5 or 10 nav agents on that, maybe one of them's you, but another one is, a bunch of non-player characters that are wandering around and stuff like that. Sometimes these guys will start interacting with each other weirdly. So those are other things you might need to worry about. But I'm thinking more along the lines of, if in real life, if you're walking through a park, there might be some shortcuts you would take. Like you might not necessarily just stay on the path that goes to the park. You might take a little shortcut, like, I can get over there a lot quicker if I go this way rather than meander through over here. But there's some of those little things that you technically would, like you might not walk through the little crack between like the outhouse and a bench, right? Something you could like squeeze through. But depending on how the pathing is working and how big of a spot that is, they might mark that as a completely legitimate path. So you might have situations where your guy acts a little funny. So those are areas where you need to go in and maybe tweak or fake it, maybe mark some areas that technically should be walkable as not walkable. That way your guy doesn't walk there. So that's where you're, having to, kind of play against the rules, play within the constraints of the game engine. How many of you have seen the movie The Matrix? Hopefully everybody in here has seen The Matrix. All right, so one of the things they talk about in The Matrix is they're in this virtual world, and the world has rules, and you have to play with the constraints of those rules. But sometimes those rules can be stretched or something like that. Well, that's kind of what we're dealing with when you're using a game engine. You're playing by their rules, but sometimes you can create little hacks to make things. Something didn't work the way it should have worked, but it looks right to the end user. So those are some skills that you'll get using something like Unity to accomplish stuff. All right, so AI pathing, NPC control. Anything else we could think about for artificial intelligence stuff as it relates to gaming? I mean, AI is becoming a big deal in computing in general. A lot of it's machine learning stuff where it's taking in large amounts of data and coming up with some conclusions based on that data that maybe a human being would never be able to process. But at the end of the day, that's not really something our video games are doing maybe yet. We fast forward 5 years or something like that. Now that you have a lot of these systems, IBM Watson and stuff like that, you might have video games that are leveraging those things where the NPCs start adapting to your gameplay, which would be kind of a cool thing where, 2 different people are playing the game and NPCs might interact with them or do things differently because of the way they've previously interacted with them. When you think about games you've maybe played today, that's done at a pretty, high level, I guess. I think about like MMOs and stuff like that. If you are doing quests for a certain faction or something, you gain brownie points for that faction. And then the next time you go and interact with them, maybe they sell you goods at a 10% discount or something like that because of your, reputation with them or something like that. Well, that's across the board for every single player. Well, if you're playing a game and, now a lot of our interactions with NPCs are scripted, right? What do you want to do? Do you want to buy from this person? Do you want to talk to them? Here's the 5 different questions you can ask them, stuff like that. Well, we're probably not ridiculously far away from, basically being able to ask an NPC using normal, English, just speaking into your microphone, asking them any question that you want. We've already, I'm sure all of you love those automated systems when you call up your bank or something like that. Why don't you just tell me in a few words what you're calling about? And you start getting in this argument with the computer. Have you run into that? Yeah, isn't that frustrating? But that's where we're going. And Google just released the thing beginning of the summer where now they're tricking people with their AIs, where they pass the Turing test, where people don't even know they're dealing with a computer. Well, you're going to be dealing with that in your games. A low population game might just interject a bunch of bots into the game, where if you've seen game bots in the past, where people are automating the play of a game, you can usually tell that they're a bot, right? Some of them are better than others, but they don't respond. You talk to them, they don't respond. And there was for World of Warcraft, there was an old bot called WoW Glider, which is one of the early bots for that game. And you could create a yo-yo effect. If you went near them, the bot was set up to avoid other players. So every single time you walked near them, they would yo-yo away and yo-yo away. So you could kind of drag them across the zone and put them in a dangerous place. Just by playing against their tendency to avoid the player. So it was kind of a fun thing to do. But you're going to start seeing things like that incorporated into our games. Now, from a game designer perspective, we might say, oh, well, that would be really cool, assuming it's done right. You don't want to be frustrated dealing with the NPCs. But at the same time, if it's done right, and we imagine moving into the future, even just a couple of years, those things are going to get better and better and better. That would be cool for our games to be completely, seems like a current trend in games is open world games. How many of you have played an open world game? Like Fallout? I guess that's the one that's coming to mind right now. Okay, yeah. I don't like open world games. What do we think? Do you like them? It feels like there's not a goal.
Depends on the open world game. There's some that I really like The Witcher 3, Breath of the Wild.
Yeah. By the way, earlier Witcher was one of the games I was trying to think of with the hack and slash type of thing. Yeah, I don't know. It might just be I don't have the attention anymore. When I was younger, I could sit there and play games for just hours on end or something like that. I can't do it anymore. Yeah, I kind of want a predefined path where it's I'm just going to beat one more level and then I'll stop for the day. Where you don't have that type thing in an open world game because you might get off this.
More linear.
Yeah, you might get off on some tangent somewhere, and all of a sudden you've forgotten what the main quest line was or something like that. So, but anyways, they're becoming very popular, and obviously they have a big audience for them.
Some of the memes about Legends where it's oh, help me, and then Link's just saying they're fishing meat.
Oh yeah. So yeah, I like you said linear. I think I like the linear games where what do I do next? And I put it on easy. Yeah, so because now I'm a completionist, but I'm also an efficiency completionist. I want the storyline of the game, but I can't beat it on the harder levels. I'm not good enough. Yeah. I want to be able to sometimes. That's what they should do in some of these games. They should, if you can't get past a certain level, they should just have an immortality switch.
Some of them do.
Well, just for the moment, you still want the game to be challenging.
Yeah, some do,
Because I remember the original Elder Scrolls game.
The modern Mario games do that.
Oh, do they?
Yeah. If you die a certain number of times, it'll just have this little box pop up that gives you basically
get past this up front.
It's an invincibility thing within.
I see.
Well,
I remember the original Elder Scrolls game. There was some cheat code you could put in to make yourself invincible. Then I went and I killed some guy in some pub or something like that, and it ended up being a major character for the end of the story. It told me that you've just killed you've broken the game effectively, but they had a system for it. I mean, so you've broken the game. You can continue on in this broken world where you can't complete certain things because this guy's dead who's a major player. But yeah, whatever. But in any case, our game engines give us artificial intelligence, physics. They allow us to write some code. They are going to have some of the design elements. This is going to come in the form of putting textures on things and lighting. So, we could say textures, lighting. You know, we can keep going down the line. Shadows, all sorts of stuff like that. Let's see, something else they will have. They will have built-in things for animation. All right, so we have a couple of different things. So how many of you have taken or are taking the animation class with one of our animation classes with Dr. Wall? Are you in it now or you've had it already? Okay. So is it the first one you're in?
Yeah.
Okay. So you guys will learn how to do some basic 3D animation type stuff. And one of the things you'll talk about is like rigging a 3D model for animation. You're going to give it, you know, joints and stuff. Like these are the places where this dude bends. And then you can actually create animations. Like, you know, if you want the arm to wave, this is what the wave animation looks like. You know, this joint moves, and this guy moves there or something like that. Or maybe it's like this one, you know, whatever. You get to decide what those are. So in Unity, you can bring things in from systems like that. For instance, you guys are probably going to use in the first class Blender is my guess. Unity has full support for Blender, but it also works with Maya and 3D Studio Max, which is actually the same product as Maya now. Well, different product, but same owner. But in any case, these are, you know, tools for creating, you know, animations at a very granular level. Now, if you bring something into Unity that's already pre-rigged, but doesn't necessarily have a whole bunch of animations pre-designed for it, he just has his joints. You can use Unity to create some simple, you know, simple animations with that. But usually you'd want to create your animations externally, even if they're simple ones, just to seem like there's some life in your guys. And we'll look at some animation stuff. We will use animations in here. We will sort of kind of create animations, but not from scratch. We'll be using a base animation to create kind of a larger animation. So transitions between multiple animations using something called a state machine that we'll use in there. So, you know, these game engines have a whole bunch of different stuff in them that allows working with pre-configured things that you got from somebody who knows how to do that, right? So, you know, while I understand the concepts of animation and things like that, I have a beginner plus strength in creating 3D models and animation or something like that. I'm not all that artistic, but I'm pretty strong at programming. So somebody else can create the model and stuff like that. Now let's bring it in here, and then I can write the code that says, when this guy starts to do this special attack, I'm going to transition to this animation, then there should be a pause, and then this animation. That's all programming stuff, leveraging the state engines, the state machines that are built into Unity. So Unity provides all these things. Go ahead.
I just remembered something else that the game engine probably does. It probably does lighting, I guess.
I have it here.
Oh.
Design elements. And these are just two examples. It has all sorts of filters and shadows and stuff that we probably as a game programmer. So that's kind of the distinction I'm trying to make here between what full game design is versus game programming. We in here are going to be the programmers who are going to leverage these engines to do the programming-esque type things. We'll dabble in some of the design stuff, but more from the point of view of either if you want to be that cross-training person who's also doing animation stuff, that's a different expertise, right? You're building this animation stuff using a different tool, then bringing it into Unity and then leveraging the widget that you built. Right, it's almost like going out to Home Depot and buying a little goblin guy that's pre-rigged with waving and stuff, you know, and you bring it home, you plug it in, and now he can wave. You know, that us plugging it into Unity and saying wave is what we will do. All right, so we'll use some built-in stuff from the course, and then when we're messing around with teaching individual skills, we'll use stuff either off the app store or off the asset store or just using primitives. Okay, so this is probably, a relatively short list, but you get kind of the picture. There's, the allowing us to write code aspect of this was a very small part of this guy. In fact, Unity doesn't even have the writing code stuff built into it. Unity, if you get Unity for the Mac, let me actually jump over to, I'm already on.
Doesn't it have its own?
It uses Mono if you're on the Mac. Otherwise, you can connect it to Visual Studio. It does now ship where you can choose with the installer to install Visual Studio 2017, I think. So it's Unity 3D. So this is the guy we'll be using here. So if we go to products, we want the free personal. I actually do have codes for us to use in class for Pro, but it's not going to make any difference for us for a while. So you want just the personal edition, then you can unlock it for Pro later. So click try personal. Accept for your whole life to be taken away. Get Unity for Windows. It should start downloading that. 2018 25F. That's probably newer than I currently have. So I'll go ahead and grab the newest just so I'm dealing with the newest. In fact, I should be able to see out here. Where's my Unity icon? 2018 1.1 F1. So that's the newest I have on here. This will grab the latest, greatest. I'll just go through the first part of this. You guys can go ahead and get it on your machines. Out of curiosity, how many of you have a laptop that you think is relatively decent that could probably drive Unity? Okay, because when we start going through the videos, it might be helpful for you to do stuff at the same time. So maybe between now and next class, go ahead and get Unity on your laptop as well, and we'll test it. We also have this room over here, but we're going to be limited on how many total computers we have, although I think we can maybe work with this many people anyways. And we can use that in the room next door. So one way or another, we'll make sure everybody has a reasonable machine. But in the shorthand, why don't we...
I'll need to clear up my massive number of tabs first.
All right, so you just go through this, accept the terms, blah, blah, blah. For us, you can choose Android build support if you want. We're not going to be using that. So if you want to keep it minimalistic, you can. If you do want to do some VR stuff, especially with like Oculus Go or something, go ahead and keep Android build support on there. But what we need is Unity, and we want Windows build support. I'm surprised that wasn't selected by default. But whatever. This actually is a different back-end engine, so this probably wasn't actually needed. I'm going to include it, though, just in case. But that should be it. You don't need Facebook or Mac, Linux, any of that stuff. If you're doing this on a Mac, choose the Mac build support. It won't make a difference. You'll be able to export it to any of these things. So we might say that Unity is cross-platform. It doesn't matter what kind of machine you're working on Unity with. You can export your game for Windows or export your game for whatever else. All right, so I'll go ahead and hit next. Download files, temporary location. It's going to delete it when it's done. We'll put it program files Unity. Hit next. And then it's just going to start downloading this stuff. All right, so it's cooking in the back. It's a pretty big download, so you might want to do it like overnight or something like that. But once you have that, it'll start the installer, and one of the parts of the installer will be, it won't do it on mine because I already have it on here, but if you're on Windows, it'll let you choose Visual Studio 2017. as your IDE for you to write your code, I would install that if you're on Windows. If you are on a Mac, you can go ahead and download. I don't think it's part of the installer on the Mac, but you can go ahead and download Visual Studio for the Mac, and then we can go into Unity and tell it to use that instead of Mono for code writing. I think Visual Studio is better than Mono for your code writing, but neither of them are deal breakers. It's just the text editor you're using for writing your code. All right, so I'm going to leave that cooking here in the background, but that's kind of the point there. All right, so Game Engine gives you all this stuff among other things. Okay. Now, language, we're out of here, what, 9:20? So we still got a couple of minutes. So we're going to call this scripting. So most game engines, as I've mentioned, they have stuff built into them for doing a lot of stuff. So you can accomplish quite a bit without actually writing any code. Now, if you want to do something that's anywhere near a game, you're going to have to write at least a little bit of stuff. But you're not going to be writing these full-fledged programs. So if you've had programming before and you have been intimidated by it, or it's like sitting there and saying, okay, well, I have to write this function that takes these three things in and reverses this guy and searches for this and sorts this, and there's a lot of algorithmic type stuff, which is important to learn in terms of learning to become a programmer, and it's not something that you'll never need in game programming, because sometimes you'll have to go and do something kind of unique. Like I said, maybe you have a collection of NPCs and you need to go through and find the guy whose name is whatever, something like that. So now you need to, search through something, be able to spin through an array of game objects, this kind of stuff. So it's not like those algorithms are non-existent, but a majority of what you do, or what you do a majority of the time in Unity, is going to say, here's a game object that I've attached a script to. I want to get his animator and tell him to wave. Okay, we're talking like 3 or 4 lines of code to do something. So the scripting is kind of the glue that melds the systems together, but the types of programming that we're doing inside of game programming is in many ways simpler because we're programming in terms of Unity's built-in tools. Kind of makes some sense? So it just so happens with Unity, our scripting language is going to be C#. It actually also supports JavaScript, but nobody uses JavaScript. C#'s the language everybody uses for Unity. If you are programming, if you're using Unreal Engine, which is kind of a competitor with Unity, the scripting language is C++, and they also have a kind of a built-in visual programming type thing, which works pretty well. But my opinion is if you're starting game programming today, the right tool to use is Unity. It's got a lot of traction in the industry. It's caught up from a visuals perspective. It was already ahead in a lot of the other perspectives. And you got some big players that have adopted it as their thing. And a lot of the programming stuff for VR is evolving the fastest in Unity. So this seems to be the current cool kid. Unreal was one of those. It was a game engine that was for the game Unreal for a long time. So it was a proprietary game engine that they then released. And for the first time, we had access to it as public developers. So it was cool for a while. But Unity, I would say, is the correct tool now. That's why we use it. All right. Questions, comments, concerns, bribes. All right, a couple of quick announcements. Usually on Tuesdays, I think it starts next week. It might be the week after. There is student, faculty, staff Bible study from noon to 1. Just go to the cafeteria, get a tray, sign in. It's free lunch, God and grub. Take it down to the terrace room, and there's a Bible study. I always go to chapel after class, so you're invited to come to chapel with me if you would like. I sit in the very front row. You don't have to sit in the front row if you don't want to, but I will see you when I see you. So yeah,